Hey there, everybody. Welcome to our first online lecture. Um, Bear with me, this might be a little choppy. So what I want you to do today is take out your notebooks. We're going to be taking some notes on this lecture. I will be embedding some pauses into the Educanon video so that you can take down notes so that you have time and you can just hit enter when you're ready. So, ready to get started? Go ahead and take out your notebooks. Okay, you're going to head a new page in your notebooks with the term solutions. It's going to be page 11, and today is the 17th of October. So that's what mine looks like. I'm also going to have you draw a little cup, just like mine, with a little bit of water in it. Okay? In my cup, I kind of used some pen. You can use another color to just highlight where the liquid is. Above the cup, we are going to start our first vocabulary word, and that is a solution. Now, in your online lab, you saw, in the online videos, you saw the difference between solutions and mixtures. And mixtures are easily separated. And you can kind of see why a solution is not, because it's evenly spread out. The solute is evenly spread out throughout the whole mixture. So it makes it a lot easier to separate out. So a solution in your notebook, a solution is a mixture in which substances are evenly distributed. Okay, moving on. Solutions can exist in all three matters, in all three states of matter. So we always think of a mixture or a solution as a liquid, but they do exist as solids and gases as well. So CO2, this is carbon dioxide. This is an example of a gas solution. Solids, you can think of things like like trail mix and stuff like that. That's a mixture. Okay, something is soluble underneath your cup. I want you to write down these two next definitions, okay? I know I have things on the other side of the cup. We'll get to that in a second. I want you to go underneath your cup. The first definition is soluble. Soluble is a substance that can dissolve. So here you can see instant coffee. It can also be your hot chocolate, which we were talking about. Something that can dissolve in another substance is soluble. Next is insoluble. So you're going to write that right underneath again. Next line down. Insoluble is a substance that doesn't dissolve. So oil and water are a good example. Oil does not dissolve in water. It's insoluble. Next, I want you to put in next to your cup and in your cup little dots. Okay? This is going to represent the solute. So what you can write solute and draw a little arrow to your little dots. Okay? This is the substance being dissolved, your solute. So in this case, you have salt dissolving in water. Your solute is the salt. Our hot chocolate would be the solute. Next is our solvent. So again, to your notebooks, the solvent, on this side. Okay. In most cases, your solute or solvent is water. So in our little cup, solvent is the substance in which a solute is dissolved. You might want to underline in, substance in which a solute is dissolved. So in this case, you've got sugar, which is the solute, and solvent, which is the water. So again, we are not always just talking about liquids when we talk about solutions. In this case, you've got some jewelry, and silver is up to 92.5% sterling silver, and it's 92.5% silver and 7.5% copper. So there's a little bit of copper mixed in a sterling silver piece of jewelry. So this is considered a solution, and the copper would be the solute because it's in a lesser amount. The solvent would be the silver. Water is referred to as the universal solvent. If something is going to dissolve in water, it's going to dissolve in water more than most other things. So universal solvent. Okay, so underneath your big cup, I want you to draw two little cups next to each other. Okay? In one of them, you're going to put a bunch of little dots, and in the other, you'll just put a few. You could see that in my pictures, my solute, I used a different color. So you could do the same thing. I have highlighters to highlight all of your vocabulary words, and you can use a different color to use your solute. So next to your cup with a whole lot of dots, you're going to write concentrated. Concentrated means that there's a large amount of solute. So you can see in this picture, this on the left would be a concentrated solution. Okay, your hot chocolate, that's when you've got like you can almost like feel the grit of the hot chocolate in your teeth because it's concentrated. It hasn't all completely dissolved. Okay, so in this picture, which you can't really see because my face is in the way, there we go. The next kind is dilute. So this number 5 would be concentrated. Over here would be dilute. So in your notebook, with the one with the small amount of dots right next to it, dilute. It means that there's a small amount of solute. Now we get into saturated solutions. This is the last thing you're going to put in your notebook underneath your 2 cups, saturated solution. This is what you observed when you did your lab. A saturated solution is when all the solute the solution can hold at that temperature is dissolved. All the solute a solution can hold at that temperature. So you can see in this picture here, some of the solute ended up at the bottom, so this is actually beyond saturated. If it were saturated, it would be just at that point where it was still dissolving, but just before, when you did your lab and you had a certain amount of grams, that's the data you were collecting, the amount that got it to a saturated solution. Okay, so the next thing we're going to do is look at solubility charts. When something is soluble, again, it means it can dissolve. Most solids, as you increase your temperature, as you saw in your lab, as you increase the temperature, the solubility also increases. You could see that mostly with this potassium nitrate. Potassium nitrate, you could see how much more it becomes soluble as the temperature increases. Some are just a little bit less dramatic, but they generally all increase in solubility as you increase the temperature. Now this chart is very difficult to kind of decipher, but what you are going to do next is fill out a worksheet where you are going to be picking out the solubility of each of these substances at a certain temperature, and I'm just going to go over how to read that quick before I let you do that on your own. So this one is a little simpler. Some questions I have written down here we can go over. So looking at this chart, this is the solubility, this is the amount of grams of each of these substances in a cup of water. Okay, so this would be 20 grams of a substance in a cup of water. And this is the amount of temperature and the increase in temperature. So which of these would be the least soluble at 90 degrees? How would we figure that out? Well, we would go along our x-axis over to 90 degrees and go up and see which one do we intersect first, because that would be the least soluble. And here we have potassium bromide. So it only takes like 42 grams to be soluble at 90 degrees. So that would be KBr for that one. So let's go to another question. What would be most soluble at 40 degrees? You'd go to 40 and go up. Most soluble would be the top line, and that's the NaClO3. Okay? So you're just reading across and then up to see which intersects last in this case, because it would be most soluble at 40. The last is least soluble at 20. Again, it would be the first line you intersect with as you go across to 20 and up, and you'd have KNO3. Now I want you to go ahead and try the worksheet. What you're going to do is try the front part and answer the questions. On the back, you're going to be taking your data from your lab and graphing it yourself. So you'll be graphing one of these solubility curves using the two substances that you picked out for your lab. If you have questions, I will be around. Good luck.